Hello, I welcome you all to your own channel MSK Learnium. Now in this video we are going to discuss about the point of contraflexure. The point of contraflexure is also known as the point of inflexion. So as you know that in shear force and bending moment diagram we have a 5 types of beam, that is simply supported, cantilever, fixed, continuous and overhanging beam. And also we draw that how to draw the SFD and BMD diagram when the load is point load or UDL or the combination of point or UDL, right? So the point of contraflexure means while you draw the shear force and bending moment diagram, so far I think you've got that the shear force is shear force is changes its sign from positive to negative. So wherever the shear force is changes its sign from positive to negative, at that point you got the bending moment is maximum. So let us imagine that, have you ever think that maybe the bending moment can also change its sign from positive to negative. So the point where it means that whenever the bending moment is changes its sign from positive to negative, there will be one point where the bending moment is become 0, right? So the point where the bending moment is become 0, that point we call it as a point of contraflexure or the point of inflection. In another way you can explain the point of contraflexure is nothing but it is a point where the bending moment is changes its sign from positive to negative and vice versa, right? So you can write that what is point of contraflexure. So write down that it is a point where the bending moment becomes 0. This is simply, right, become 0. Obviously the bending moment is becomes 0 only when it is changes its sign from positive to negative, or you can say where the bending moment changes its sign from positive to negative, right, or vice versa, or you can say the vice versa, right, means maybe the negative to positive also. So the point of contraflexure or the point of inflection, both are same, right? So here you can write that point of contraflexure or point of inflection, right, inflection. Is it or not? So the point where the bending moment is changes its sign from positive to negative, or that where the bending moment is become 0, that point we call it as a point of contraflexure and point of inflection. So we will see that means with worked example we try to find the point of contraflexure in a given beam, right? So specifically we will solve out the problem which is related to the overhanging beam. So overhanging beam means what? If you remember that overhanging beam is nothing but the beam which is extended beyond the support. So let's say you have a two support is there, right? This support is A and this support is B, right? So if you see beyond the support we have this portion is extended, so that portion we call it as a overhanging portion. So it's not like that always one sided overhanging, it may be from the both side also, right? So another beam will be like this. So this is one of the support and this is another of the support. If you see, then you found that there is the overhanging portion from the left hand side of the beam as well as from the right hand side of the beam. So these two are the example of the overhanging beam. So we have one problem is given, that the problem is on the screen, right? So here you can see that draw the SF and BM diagram, means shear force and the bending moment diagram for the overhanging beam, right, carrying a UDL of 2 kilonewton per meter over the entire length and a point load of 2 kilonewton as shown in the figure. So figure is given in the question. Locate the point of contraflexure. So this is what you have a question, that one overhanging beam is given on which the UDL as well as the point load is acting, right? So you have to find out, means first of all you need to draw the SF and BM diagram, that is shear force and bending moment diagram, and then you need to find out the point of contraflexure. So point of contraflexure will get only when the bending moment will changes its sign from positive to negative, right? So first of all, this you can see the analysis of the beam is how the beam of 6 meter length, right? The overhanging beam of having length is 6 meter up to 4 meter, the beam is simply supported. Means what? From A to B you have a 2 support is acting over the 4 meter length, but beyond the B there is a 2 meter length is there which is extended beyond the support. So this 2 meter is known as the overhanging portion. If you look at that, on the beam we have a UDL is acting of having magnitude is 2 kilonewton per meter over the entire span, right? And at the extreme end, means at the right hand of the beam, the 2 kilonewton point load is acting at the point C, right? So first of all, what we need to do, we have to draw the SF diagram, and then we need to find out the BM diagram, and then we'll find out the point of inflexion or point of contraflexure. So for that, as you have seen that you have a simply supported beam, that you need to find out the reaction at A and B. So simply equilibrium condition we will apply. That means what? Let's say that at A the reaction we call it as a RA, and at B the reaction we call it as a RB. So these two reactions, that is these two reactions are acting vertically upward, and this will be balanced by the vertically downward load, that is UDL as well as the point load, right? And then you can find out the moment and do. So let's do that. See here, I'm leaving this space. Why? Because here only I'll draw the SF and BM diagram after calculation. So first of all, I'll take fresh page, and then we can find out the, so I'll show you this question, so that's why I'm taking it out. Just hold on. So now you can see, first of all you can find out the RA and RB. So for that, you know already previously we already solved 2 more questions, that is on the you can find the link, right? So RA plus RB is equal to what? That this point load is UDL is given. So this UDL should convert it into point load. How? That the UDL up to what length it is acting? Up to a length of 6 meter. So when you multiply this UDL with the length over which the UDL is acting, that UDL will become point load. So now we are going to convert this UDL into point load by simply multiplying with the given length, right? That is 6 meter. So you can say RA plus RB is equal to 2 into 6 plus one more load is there, which is point load, so 2, right? So when you simplify, you'll get this RA plus RB is equal to 14, right? So let's say this is equation 1, right? Now what we can do, we can take moment about A. So you can take the moment about C also, right? So this is A, B and the C. So I am taking the moment about A. So at moment about A means you can see how many loads is acting on the beam. This reaction, this point load and the UDL. So as you are finding the moment about A, so you need not to take this RA, right? Why? Because it does not satisfy the perpendicularity condition. So while you take the RB, so RB means it is acting vertically up, the distance is this much, right? And again when you take this 2 kilonewton vertically down, the distance is whole. This 2 kilonewton is also acting downward, this is UDL. First you convert this UDL into point load. How? By multiplying with the length over which the UDL is acting. When you multiply this UDL with the given length, that UDL will become point load. Then the point load will act at the center of gravity. That center of gravity is nothing but the half of the span. It means that the point load will act here, right? So this is your moment will get, right? Now, so as again if you see this RB, when it acts, the rotation of the beam will take place anti-clockwise, and because of these two downward forces, the rotation on the beam will take place clockwise. So clockwise will be one side and the anti-clockwise will another side. Okay, so these all we have discussed in detail actually in engineering mechanics also, and in SFD and BMD diagram also. So now, so you can say taking moment about A, right? So what is that? RB into 6 is equal to 2 into 6, right, into 6 by this 2 into 6 means it's become point load, and where this point load should act, this point load should act at the center of gravity, plus point load is given 2 and this is at a distance of 6, right? So now, sorry, RB into 4, I'm very sorry, that RB into 4, right? So this will be 4RB is equal to this, let's say this 2 will get cancelled, 36 plus 12 is 48. So RB is equal to 12 kilo Newton. We got the reaction at B, right? Now when you substitute this reaction into this equation 1, you will get the RA. So now you can say RA is equal to 2 kilo Newton. Got it? Right. Now we got the reaction at A and B, okay, and then we can start our calculation for SFD and BMD, right? So let's do that. So here you can write, just wait, that SFD, that is shear force diagram, right? So shear force diagram means what? First of all, I can start from the left, right? So let's see that. At left section, shear force is what? That is plus RA, which is left side upward is positive and left side downward is negative. So now what I'll do, that I can consider any section XX between A to B, right? At that section we will find out the shear force equation, right? So now what I'll do, that here for simplicity just I'll draw one figure, right? Whatever the figure is given to you right now, so then it's better to understand. So let's say this is your beam and that UDL is acting over the beam, is it or not? The UDL is acting over the beam, and here you have a one support and here you have a one support, right? And this is the point load is acting, which is 2. This is also 2 kilonewton per meter. This is your A, B and C, right? So this distance is what? This distance is nothing but the 4 and this distance is 2, right? So now what I'll do, that I'm considering one section XX at a distance of X from, XX at a distance of X from A, right? So at this section we are considering the shear force, right? So you can say, so this is just additional, right? So you can say consider any section XX between A to B, right, at a distance of X from A, right, from A. So now you have considered any section XX at a distance of X from A. At this section I am considering the we are generating the equation for shear force. So shear force equation is what? Let's see that. Fxx means this is the shear force at XX, and then that shear force is what? The force and the sum of all the forces. So one force is a reaction and one is the UDL. So reaction is what? Vertically upward, left side upward is positive, so you can say here that is RA, right? And left side downward is negative, 2 kilonewton, and up to this it is X, means 2 into X. So you can say RA minus 2X, right? So this is the shear force equation we got at XX section from A. Now we need to find out the shear force at A and shear force at B. So if you look at the shear force at A is what? The shear force, at A X is equal to 0 and at B X is equal to 4. So when you have to find out the shear force at A, it means that you need to put X 0, and when you have to find out the shear force at B, you need to put X is equal to 4. Got it? Right. So now you can say that first time means we need to find out that here shear force at A, right? So at A x is equal to what? 0. So you can say FA is equal to, this will become A now. So FA is equal to what? RA. RA is nothing but the 2 minus 2 into 0, right? Which is your 2 kilonewton. So shear force at A you got 2 kilonewton, right? Okay. And one more thing, that you can put this value here itself, that is RA is 2, so 2 minus 2x, just for simplicity, right? Now, so shear force at A you calculated. Now come to the B. At B, what is the length? 4 meter. It means X, this section is reaches to here. So when this portion is reaches to here the section is become 4 meter, right? So X will 4 will put. So now if you find, just wait, right? So shear force at B, right? So at B, X is equal to what? 4, right? So FB is equal to 2 minus 2 into 4, right? So 2 minus 2 into 4 means what? 2 minus 8, that will be minus 6 kilonewton. So it means that you can see one more thing you can observe now, that shear force changes its sign between A to B from positive to negative. That means that between A to B there will be one point where the shear force bending moment will become maximum, right? Why? Because dm by dx is equal to F. That derivation you know, we already derived, right? So here you can say that you need to tell where the shear force has become 0. So now, so here only I am showing you that you can write one statement. That a statement is very easy, that will be, just wait, yes, right? So now you can say that here, since not since and all those things, the shear force changes its sign from positive to negative, right? Between A to B. Means shear force changes its sign from positive to negative between A to B. Hence the shear force becomes 0 between any point, at any point, at anywhere, at any point itself, right? At any point between A to B, right? So it means that whereas the shear force will changes from positive to negative, there will be must one point where the shear force is becoming 0. That point we have to locate. So if you see that you already generated the relation for shear force between A to B, that is what? RA minus 2x, means 2 minus 2x, this is the shear force at xx, and this xx is lying between A to B, which means that if I put this shear force value is 0, we'll get this position, right? Now, so you know that here you can say therefore that fxx is equal to what? 2 minus 2x. That leads you that 0 shear force will putting 0. Why? Because we are considering that, means we found that shear force changes its sign and it will become 0. So it's 0, we are putting 0. 2 minus 2x. So when you simplify, x is equal to 1 meter. Now you can say that shear force is become 0 at a distance of 1 meter from A, right? So in this case, that the bending moment will be maximum at a distance of 1 meter from A. That we will do later on, right? So now the shear force calculation is over. No, it's not over yet. That till AB is over right now. So now we'll move to the BC, right? So here you can say that shear force at any section, right, between B to C, right? Same thing at a distance of x, From where? From A. Previously you found that shear force between A to A at a distance of x from A. Now the BC, that is the overhanging portion, is still left out, right? So that section you have chosen, and then you consider that shear force, means shear force equation you are going to generate between B to C from A. So I'll show you with the diagram, right? Then that is easy. This is your figure, that is beam is given. This is the UDL is acting over the beam. Rough figure I am drawing, right? So this is your one support, let's say A, this is the B, right? And this is the overhanging portion, right? Now so this is A, here you have a B, and this is the C. Here the point load is acting, whose magnitude is 2 kilonewton, and the UDL is acting, whose magnitude is 2 kilonewton per meter, right? So this is your 4 meter, and this is the 2 meter. Now what I'll say, the shear force at any section between B to C, this is your B to C, right? So at B to C, let's say this is XX, and this distance is X from A, right? So now, so till here, how many load is there? RA, RB, and the UDL, right? So now you can say this is your RA, this is your RB, right? So shear force at this section BC at XX you are finding, right? So now you can say the Fxx is equal to what? Vertically left side upward is positive, that is RA, right? Minus up to this section. What is the load? 2 kilonewton per meter, and the distance is 4 meters. So when you multiply, you have to get point load 2 into 4 minus 2 into 4. Why minus? Why? Because left side downward, right? Again this is a reaction, vertically up, so left side upward is positive, plus RB, right? And this portion, this much, I'll show you here, right? This portion we have not taken, means this much of UDL we did not consider, now we are considering, right? So this portion is what? That is 2, and this distance is what? X minus 4, right? And minus only, that is minus 2 into X minus 4. Understood? Now we'll put that values. RA you have 2 minus 8 plus RB is 12 minus 2x minus plus 2 4 the 8, right? So this minus 8 and plus 8 get cancelled. 2 plus 12 is 14. So this is what you got, that is 14 minus 2x, right? So this is the shear force at XX is this one, right? Between B to C, this shear force equation you got for the B to C. Now again, if you want to know at B what is the shear force and at C what is the shear force, we can put X values, right? So if you look at B, X is equal to 4 we have to put, and at C X is equal to 6 you need to put. One by one we'll put the values and see what is the shear force, right? So here you can say that shear force at B, right? So for that X is equal to what? 4. So FB is equal to, this is 14 minus 2 4s are 8, that is 6, right? Kilo Newton. If you look at previous data, right, I'll show you that shear force between A to B we got minus, right? And again between B to C, because of that reaction the shear force is becoming positive, that is plus 6. So shear force it changes from minus to plus, right? Then you can see at C, at that is shear force at C, right? So at C X is equal to 6 we can say. So FC is equal to, what is that? 14 minus 2 into 6, 14 minus 2 into 6, that is plus 2 kilo Newton. And at C you can see at C the 2 kilonewton point load is acting, so our calculation is correct, right? Now we need to find the bending moment diagram. Okay, so just wait. So now you can see here that bending moment diagram. Where is the pen? Yes. So you can say very fast, right? So you can say the BMD diagram, right? Bending moment diagram. Is it or not? So again you can say the bending moment at any section between A to B, right? So you can say, you can generate the equation bending moment at any section, right, between A to B. A to B means what? That is MXX. I'll show you the same, the shear force which you have taken, that is A to B. Where is it? Yes. So this is the, see, for shear force A to B we have chosen this section XX at a distance of X. So here you are finding the bending moment is what? Force into perpendicular distance, that is RA into X minus, why? Because RA into X positive, why? Because from the left hand side the rotation of the beam will be clockwise, right? But because of this UDL, this will be anti-clockwise, means clockwise from the left side, right? So it will be negative and this will be the positive. So now you can say that equation will be force into perpendicular distance, that is RA into X minus UDL is what? 2, and that is X we have considered, so 2 into X, and this become point load. Where this point load should act? This point load should act at the half, that is X by 2. I'll show you again. That is what? This is the, at this section you are finding the moment, right? At this section. So at this section, force into distance, RA into X, and this load is what? 2, it's X. So 2 into X, this become point load. Where this point load should act? It should act at the center of gravity, that is X by 2, right? So because of this reaction it will be positive, and because of this UDL it will be negative, right? So the sign convention you know. So when you substitute these values, that RA is nothing but the 2X, right? This 2 and this 2 will get cancelled, minus X square. So bending moment between A to B at a distance of XX, sorry, at a distance of X from A to B is 2X minus X square. This is the equation you generated, right? Now if I want to know that bending moment at A is equal to what, so I can say bending moment at A, right? At A, X is equal to what? 0. When you put this X 0, the bending moment will be 0, that is MA is equal to 0. 2 into 0, 0 minus 0 square. Already you know the bending moment at the end will be 0, right? So then bending moment, directly I am finding bending moment at B. Is it or not? Bending moment at B. So at B is what? That is X is equal to 4 meter you have to take. That is MB is equal to 2 into 4 minus 4 square. That is 16 minus 18. 8 is minus 8 kilonewton meter. Right? Now, then one position you have located where the shear force is become 0 in this question. That is shear force is becoming 0 between A to B at a distance of 1 meter from A. So now you need to find out the maximum bending moment, right? So here you can say that maximum bending moment at where? At X is equal to 1 meter. Why? Because at X is equal to 1 meter we found the shear force is become 0, right? So now you can put X is equal to 1 in this equation, you'll get the maximum bending moment. So here I am writing M max is equal to what? 2 into 1 minus 1 square, which is 1 kilonewton meter. Positive, right? So this is what you got the bending moment at A, B and maximum bending moment. Let's say this is any point that D you can consider, right? Now again you can observe very carefully that at B the bending moment is negative and between A to B the bending moment is 1. Why? Because this is, see that here it is 4. So here you are getting the bending moment is minus 8. But 1 means 1 meter will be between anywhere. That let's say it is here. So here you have a positive and here you have a negative. It means that in this section the bending moment is changes its sign from positive to negative. So means between A to B there is one point where the bending moment is become 0 and that point we call it as a point of contraflexure, right? So this is the climax of the question, right? Now just wait. So now you can say here that maximum bending moment we calculated. Again you have a one more section, that is B to C, right? Okay, so you can say, and again if I say bending moment at C means at the end will be 0, so bending moment at C, right, that is MC is equal to 0, at the end it will be 0, right? Now you can say that here you have to write some statement that bending moment changes its sign between A to B, right? A to B means what? From positive to negative, hence bending moment becomes 0 where? Between A to B, becomes 0 between A to B, right? And that point is known as the point of contraflexure, right? So you can say here in fresh, I can show you. So here you can see, just hold on this, see. So you can say the hence therefore the point of contraflexure lies between where? A to B, lies between A to B, right? So you can say mxx is equal to what you got? Mxx is nothing but the 2x minus x square, right? So bending moment is become 0, means 0 is equal to 2x minus x square. So you can say 2x is equal to x square. 1x will get cancelled, means x is equal to 2 meter, right? So point of contraflexure is 2 meter, at a distance of 2 meter from A, right? So it means that bending moment will change its sign from positive to negative at 2 meter, right? So this is what we calculated all the values. Now we need to draw the shear force and bending moment diagram, right? So here, wait, just hold on for a second. Where is the question? Yes, sorry. So this is the question you have, right? So here you have a reaction B. This is RA. Just wait. Just I'll show you properly, right? So so this is RA, this is the RB, this is not support, this 2 meter is given, that's why it is, right, 2 meter, and this is your 4 meter, right? Now, so what we need to do, that we have to draw the shear force bending moment diagram. So here I'll drawing one line, okay, and here also I'm drawing one line, right? So this is your, let's say this is your shear force for shear force diagram. So shear force at A is what? That shear force at A you got 2 kilonewton positive, right? So you can choose any point, let's say it is the 2 kilonewton, right? And the shear force at B is your, and shear force is become 0 at 1 meter here, let's say this is 1 meter, right? And this is the load is given, so this one load is shown, right? Shear force at A is 2, shear force at 1 meter is become 0, and shear force at B is minus 6 kilonewton, right? And then again at B, between B to C, the shear force is become plus C. So let's say this is 1 point, right? So how it will be? It will be like this, is it or not? So it is going from negative to positive, right? And then again at C, it is it become 2 kilonewton. So this is 2 kilonewton, right? Okay, so this is your positive, negative and positive, right? The magnitude is here 2, This is minus 6 plus 6 and 2, right? So this is your A, this is your B, and this is the C. Let's say this is one section, that is one position which you got. This is the D, right? Means that D shear force is becoming 0 right now. Now we need to find out the bending moment, means we have to draw the bending moment diagram. So for that I'll do it here. That let's say this is your line, that is for the beam, right? This is load, this is the load in intermediate load, right? So bending moment at A we got 0, bending moment at C we got 0, bending moment at B we got, it is minus 8, right? So it will be suppose here, right? And at D, means where the shear force is become 0, it is plus 1, which is maximum, right? So plus 1, which is the maximum. So let's say it is here, right? So throughout the beam, the UDL means the distance, while you're finding the bending moment, you got that force into distance, and distance power is 2, right? It means that the curve for bending moment will be the inverted parabola, right? So this is like this, okay? And here, that at 2 meter the shear force is becoming 0. So let's say this is 4, so it is will be 2 here, right? So shear force is like this, right? For A to B and B to C, again it is inverted parabola, right? So now this is positive, negative and negative. This is the 1 and this is the 8. A, your B, C, D, where the bending moment is maximum, and let's say this is E, where the bending moment is 0. So this is your point of contraflexure, right? That is point of contraflexure we got as 2 meter, right? So this is what you can draw the shear force and bending moment diagram. So this is all about the today class. In next class we will solve some more problem. So please do like, subscribe, comment and share this channel. Thank you.